Joel, I think you're muted.
I am muted. That is very embarrassing to start things off that way. Welcome to the eighth session of Office Hours. This is our monthly live stream where we talk about all things ngrok, we demo new features, and we try to take you from having maybe zero understanding about how ngrok works to being able to use it in production. If you have questions at any time, feel free to drop them in the chat and we'll try to get to them. Otherwise, we've got plenty of Kubernetes related things to talk about. And I know a number of you are very excited about that. My name is Joel. I work at ngrok doing all sorts of things, DevRel and marketing. And I've got two people here with me today. First, let's talk to Sachin. Sachin, you are kind of joining me as co-host to talk about some deep Kubernetes stuff. Take a minute to introduce yourself to everybody.
Yeah, thanks, Joel. Hey, everyone. My name is Sachin. I'm a technical support engineer here at ngrok. Been here since January. Yeah, really excited to interact with all of you today. Really excited to kind of go into some of the new Kubernetes offerings that we're working on that are currently in production. And yeah, when I'm not helping Joel out with stuff like this, I'm like the front-facing line for all of our users, so helping out with implementation, support tickets, that kind of thing.
Awesome. Amazing. Thanks so much for joining. Excited to see what you've been cooking on Kubernetes bindings. We also have a special guest today, Aishika, our new community manager. Aishika, why don't you take a minute to tell people what a community manager is if they're not familiar and what you're excited to work on?
For sure. So, hello everyone. Greetings from San Francisco. I'm Aishika and I'm joining ngrok as a technical community manager. My work is going to revolve a lot around talking to you folks, reducing the friction that you're going to face with using ngrok and, pretty much anything that you want to basically work on. And I live at the intersection of code community and content. And yeah, that's it about me. I'm going to let these two steal the spotlight today, and I'm going to be here backstage talking to you folks, answering a couple of questions that you may have. So thank you so much for having me here. I'm going to be around more for the next office hour sessions moving forward. So yeah.
Awesome. Thanks again for joining us. Yeah, definitely. Expect for those in the audience to see Aishika around plenty more on office hours and in all of our other places in the months to come. Very excited to have you with us and to work on all sorts of cool stuff with you. And yeah, hi to everybody who's in the chat as well. I'm glad to see we've got a sort of global audience already. It's fantastic. I mentioned earlier that we are going to talk a lot about Kubernetes today. I've got a demo that shows how to set up Kubernetes ingress to a self-hosted LLM, which is a very popular use case at the moment. Sachin is going to demo something that we call bindings, which allow you to do all sorts of cool stuff like projecting services into a cluster or letting two clusters communicate with one another. But I think a lot of people come to these office hours sessions, and I've gotten this feedback from a few folks in the past, where we tend to kind of jump in too deep, too fast. We kind of assume that you are familiar with all sorts of things ngrok, and we jump into a really complex production use case, and you want more of that 101 level understanding of how things work. So before I get into anything Kubernetes, I do want to take a minute to show how ngrok works with its fundamental use case that's been around for a decade, which is that you have a service that you're running locally. That could be an app, that could be an API, and you want to make that available on the public internet without having to deal with a ton of networking complexity. So let me share my screen, and hopefully you all can see this. And I'm trying to make this as big as possible. We got some feedback from the last session that it was kind of hard to read. So, if that is also the case today, let me know and in the chat, and I will try to kind of continue to optimize the way that this works. What I have Olama, which is a very popular open source project for managing LLMs on a machine locally, self-hosting them. I have that running on my laptop, which I'm sharing the screen from right now, and I can Ollama makes an API endpoint available, and I can send an API request to that endpoint and get a response. So what I'm doing here is sending a curl request to localhost port 11434, specifying the model, a very basic question that I would like it to answer, and we can send that, and we will get a response back. And you can see, this Gemma model is doing its best to answer why the sky is blue. Fantastic. That's great. But again, like, what if I want to share this LLM, share these results with somebody else who's, even like somewhere in the next cubicle over from me in the office, or in a different country around the world? You can't, nobody else can send this curl request to localhost, because their localhost is different from my localhost. So this is where ngrok comes in. And if I want to share this with someone else, I can start up ngrok from the command line. We're running ngrok. We say we want to start an HTTP tunnel on that same port that we just used on localhost 11434. I'm going to make this available on this static URL and hit enter. And I need to change my auth token. I forgot to do that. Give me a moment while I do that. I'm not going to share my screen for it, because otherwise everyone gets to see my auth token. And Sachin, if there's any questions in the chat, feel free to kick some of those off while I fix this.
Yeah, absolutely. Yeah, if anyone has any questions about anything, anytime, just drop them in the chat, and we'll do our best to answer them.
There we go. We're back up and running here. Let me share my screen again. These things always, and I just shared the auth token again. You just saw it. So I'm going to have to go back and change this once the session is over. I did all that work to try to avoid it, and did it anyways. All right, so now you can see that I have this endpoint available, this Ollama service available on this public URL. Anyone can feel free to hit that endpoint if you'd like, and see what kind of results you get. But I will show what that looks like on my system as well. So same curl commands, but instead of localhost, we're hitting this public URL. We'll do that. We can see the request show up in our agent as it's logged there, as well as in the dashboard in our traffic inspector. And you can see getting a response from the LLM, even though it's like routed through the ngrok network and back to my system. So anyone can do that. Maybe we'll get some other people. Make sure to put API/generate if you are trying to query this. And I will drop that sample in the chat so anyone can just kind of copy and paste it and see how it works for themselves. Any questions about that? I don't know how pasting in curl commands looks and works in StreamYard, but yeah, if anyone wants to, feel free to hit that endpoint. Feel free and let us know what kind of responses you're getting. Okay, it looks like folks are feeling good about that. Again, if you have questions about like fundamental use cases for ngrok, or why you might want to use it at all, we have plenty of resources in our docs. We also have a great support team. Sachin is one of those folks that if you have like a production use case and you're trying to fit ngrok into that, and email our customer success team at support@ngrok.com, they will be more than happy to walk you through what all of that is. Fantastic. So let's see here. I was maybe going to talk about what Kubernetes is for a moment. I'm curious about where folks are in the chat here. Like, should I take 2 minutes and do a Kubernetes 101, or should I just link to a couple like videos that our own Kubernetes engineers have put together that could like set you up on your free time? And all it takes is one vote, and then I will go in that direction. Otherwise, I'll just jump straight into a demo of using our Kubernetes operator. Yeah, John. John's question is: this is a very common. Oh no, sorry, that's the wrong. Says he's trying to hit that endpoint and seeing that it says Ollama is running. what you need to do there is make sure that you add /API/generate to that URL, and that will send it straight to the appropriate path for the Olama API. And we've got a couple people saying do the overview, so let's do the overview. I don't have any visuals to go along with this, so you just have to bear with me as I talk for a few minutes about what Kubernetes is. But we have to, before I can really talk about what Kubernetes is, I think you need to talk about what containers are, because containers are the fundamental technology behind Kubernetes. So containers are a way to package any service, whether that's an app, a web app, or an API, alongside all of its dependencies into what we call an image, which then you can also configure like which ports you want that image to listen to and what environment variables you want to kind of influence the behavior of the services running in that image. Which that then allows you to publish the image to a place like Docker Hub or a different registry and be able to pull that down onto other machines, so that like if I'm running a Docker container on my machine, I can share that with Sachin. Sachin runs that on his machine. It runs identically. It's, you don't have those issues anymore of like, it works on my machine, but why doesn't it work on your machine? It really standardizes the way that services and applications run. So that's containers in, a minute or so. There's so much more that you can learn about containers. There's like hours long videos about containers if you want to go deep. But to, kind of lead that into Kubernetes, Kubernetes is what's called a container orchestrator. And that means that it's a way to deploy and scale many containers at once without having to set up many different servers or many different Docker instances and try to route between them. So with Kubernetes, you write a YAML file, which is called a manifest, that declares what images you want to run. Again, like that's kind of like the containers that you want to create, how many copies or replicas of that image you want or need, which ports you want that to listen on. And when you apply that file to your cluster, Kubernetes automatically creates all the pods, which contain the containers that contain the images, and sets up all the internal networking that you need to have those pods and the services running in them communicate with one another on an internal network. And that's what folks call a desired state, which is like you declare what you want, Kubernetes takes over and deploys all of that for you. And the great thing about Kubernetes is that like during unfortunate circumstances, like a container crashing or, you're experiencing like tons of extra load, it can do a lot of things automatically to help you deal with those issues, scale outward, restart pods, and make sure everything is running smoothly. So Kubernetes helps a lot when you have these like deployment level concerns that you want to deal with, but it actually leaves you in a similar situation where that I was showing with running a service on localhost, in that a Kubernetes cluster has an internal network that is unique to itself and nothing can access it by default. Even if I'm running a cluster on my laptop, my work machine, I can't curl into those services because it's like an internal network within my internal network. And it's all inaccessible, especially from anyone else in the world who might want to access those things. So you need ingress into your Kubernetes cluster and into your services, much like you need ingress into a service that you're self-hosting, and you want to use ngrok for that. So ngrok also now lets you do Kubernetes ingress, much the way that it does ingress into just individual services. And we like to think that the ergonomics of using that are very similar, and the experience is just as good as using ngrok on the CLI. So I have a whole demo around this, but again, like let's take a moment to see if there's any questions. Sachin, I don't know if you have places that fill in the gaps, things that I didn't mention that you think are important. Kubernetes is a massive topic that we could probably talk about endlessly.
Yeah, absolutely. I see a question in the chat from Gavin about he's saying, I've used the operator before, would be nice if it could act as an ingress for multiple applications and pods. To answer your question, yes, that is possible. So if you have one application running in one Kubernetes cluster and you want to route if you and you want to have it communicate with an application that may be running in a separate cluster or even within a different service within that cluster itself, you can use the operator and ngrok to essentially route between services that are running within the same cluster and services that may be isolated in different environments. And that is one of the powerful things that the operator is able to do. We'll go into some of the different ways that you can do this as we kind of go through these office hours. But the short answer is yes, and there's a couple different ways to do it. We have our agent endpoints that you can use. We have our cloud endpoints that you can create within our dashboard that allow you to do the same thing. And then it's all done through the deployment files and through the files that you're applying to your clusters. So there's a couple different options that you have, and we'll definitely be showing some of those going forward. But great question.
Yeah, fantastic question and a great response. We'll jump over to John asking about why would you want to run multiple copies of the same container? And that's another really great question. I think there's many different reasons that you would, but I think the core reason is this idea of kind of combined resiliency and scalability. So that if you're running one copy and let's say somebody does something to your service and you hit an edge case, like a bug that you've never experienced, your service crashes and all of a sudden nobody can access the service anymore until you go in and like maybe manually restart it, or Docker goes in and restarts the service and kind of gets things back up and running. If you have multiple copies or replicas, Kubernetes can then route to the ones that are still functioning while it takes care of restarting the one that's crashed. And then, yeah, scalability. You can specify how many copies you want. So if you get, I don't know, go on the front page of Hacker News and start getting slammed with new users, you can say, I don't want 3 copies, but 20 copies. And that lets you kind of scale up and handle the load more elegantly. Sachin, are there others? Those are the ones that I think are most like basic level, like 101 level scalability reasons.
No, that's like on the nose for sure. Another use case that comes to mind which is a scenario that you'd want multiple copies of the same container is when you're developing your application. So you might have one container that's running the version of your application that you want publicly available, your production version, let's say. You might also have another copy of that same container that's running, but it's your development version. So this is the container that when you're making changes to your application, you're pulling the updated Docker image into that container to keep it isolated. And what the advantage of that, instead of just like developing locally and going through your normal DevOps flow, is that you can route production traffic to that that container that's running the dev version of your product, to see how it holds up against production traffic. So there's a lot of different configurations, a lot of different setups. But what Joel said and the scenario where you're developing against something, that is, I think, that's like one of the most powerful aspects of running multiple containers in the same environment is. And ngrok is one of those tools that allows you to set up your environment such that it makes this entire development process a lot easier compared to pushing a new container up to your like development environment, having to run a bunch of CI/CD tests, and then maybe changing a lot of networking config stuff just to see how it would hold up against production traffic.
Yeah, for sure. And John also then followed up, like, is this kind of like OpenAI running tens of thousands of copies of their models? And it's probably similar to that. I mean, I'm sure OpenAI is doing things that Sachin and I have never encountered or could comprehend in terms of their infrastructure and how they deploy. But that is the same idea. It's like when you run ChatGPT, whether in the web or with an API, like not everyone is hitting the same copy of the service. There are going to be many, many replicas, probably also in multiple regions around the world, and maybe even multiple cloud providers. so that they can fail over if like Google Cloud crashes entirely. They are set up and ready to go on AWS. Same for different regions. At some point, it becomes not running multiple copies of a container, but multiple clusters themselves to be able to handle the resiliency and load. So I'll take a minute as maybe later as Sachin is going through his demo to dig up some of those like 101 level container and Kubernetes resources that I had mentioned earlier to help people kind of get familiarized with those. I just have to dig through some internal docs to be able to find those again. I think with that in mind, like feel like we've got kind of the questions answered, and we're maybe ready to see what this looks like in like what Kubernetes ingress and what, you know, these services and pods and everything looks like in a sort of real world use case, if you will. I'm going to go ahead and share my screen again. And I'm assuming that like the fidelity of the terminal was decent enough the first time. I didn't see any complaints. Sachin, did it seem okay to you?
Yeah, I can see it fine.
Okay, perfect. So like I said, before we kind of started answering the questions, is that like ngrok on the CLI makes it really easy to have ingress, and that you can have traffic from outside your system come into your system and access a service. We do that very same thing with our Kubernetes operator, and it works very similarly. So I'm going to walk you through having a cluster with a single service running on it, and it's actually another Ollama instance. But you know, just because it's a great demo and you can kind of see the one-to-one of the CLI version and the Kubernetes version. So just to kind of let's see here. Yep. So this is maybe I should use the longer version instead of the alias. So when you access and manage and kind of deal with Kubernetes clusters, you use a CLI tool called kubectl or kubectl, or people have different names for it. And this is just me showing that I have this Ollama pod up and running. And it's actually running on the same, or it's listening on the same port as before. So 11.434. And what I can do is like, I can open a port in my Kubernetes cluster to be able to access it. I'll go ahead and do that. And this is like port forwarding kind of stuff that people don't really love to do. It's kind of fragile. You need to have this port forward like service running at all times. And hopefully we get there. The service spits out an answer. It's thinking, okay, here we go. So again, you can see that like I have sent a request to Ollama, now running on a Kubernetes cluster, and we're getting a response from that as well. And that's all great again, but we have the same problem in that nobody else can access these things. Like nobody else can, like maybe I'm self-hosting an LLM on behalf of my company and I want developers to be able to use it or build off of it, or we need something in the front end that says like ask AI, and we want that to be populated or answered by our self-hosted LLM. So what we can do is use the ngrok Kubernetes operator for that. And I already have it installed. The setup process isn't particularly interesting, but this is to kind of just show that I have these services running, the manager and the agent that kind of watch for Kubernetes services and will make them available for you. So then the question is like, what is the operator equivalent of ngrok, HTTP, et cetera, et cetera? There's a few ways that you can do this. But you know, if you have like, there's things called gateway API, there's ingress resources. These are ways that, you know, you can configure and say like, I want to make this service available on a certain port, on a certain host name. We also have our own custom resources that you can use that make that process a little bit simpler. And that's what I'm going to show you today, is like how to use kind of the ngrok opinionated way of doing this to get your services up and running. So let's see. We have That's the service, olama-ingress.yaml. So this is what I had mentioned. This is an example of that Kubernetes manifest file, that YAML file. And what this is doing basically is saying, like, we want to create an agent endpoint. This is, just kind of ngrok terminology to say, like, I have a service that I want to create an endpoint for, and I want to use the agent to be able to do that. This is the public URL that you will be able to access once I get this up and running. Again, just like running that in the CLI. And then this is the sort of the networking, like the internal networking location of the Olama service. And the way Kubernetes networking is that, like, this is the name of the service, Olama. Default is the namespace that that the Olama service is running in, and this can change depending on whether you change the namespace when you deploy a deployment or a service. Sorry for using so much terminology. I know maybe for some of you it's like, what does all this mean? But again, some of those other resources will be really helpful to kind of like get caught up to speed on what all this is referring to. And last but not least, we want to like, this service is listening on port 11434, just as it was on the CLI. And I can go ahead and do kubectl apply, and then olama ingress.yaml. So we can see that we've created an agent endpoint, and that's fantastic. And if I go back and curl this, this is the exact same curl command that I had before, except that now we're going to 008, being office hours 008 dash K8s. And that means that we're going into our Kubernetes cluster. So let's see if that works. And again, takes a minute. This is an LLM running locally on my machine without any GPU acceleration. So, it's not the fastest thing in the world. Definitely not like a production grade setup here. And we get a response. We see that it works, and we're getting, we're taking requests from the public internet, routing them through ngrok into the Kubernetes operator and into the Olama service, which I think is pretty cool at how simple that can be with just, 6 or 7 lines of YAML code. Other ways, it's much, much more complex to do that. So I'm going to take another moment to see if there are any questions about anything so far Kubernetes operator specific, because I know that can be a lot to digest. Yeah, so we've got this question about, like, how does ngrok fit with Kubernetes, and that's the idea. Ishika posted a doc about, like, the way, kind of like some of the setup around, like, how to get the ngrok operator working with your Kubernetes services. And I showed just one version of that just now, of how you can use one of our custom resources. But again, there's many different ways that you can do this. Ian, I'm glad to see that, you're working on this workflow. Glad to hear this is helping. If there's other ways that we could be of help, like, email myself. I'll post my email at some point. Actually, I'll just do it right now. You can email support. We would love more feedback on the experience of using the operator, because it is very fresh. It's in a lot of development, and we would love to hear how that works. Paulo asking about the license and cost for the operator. Sachin, do you want to handle that one?
Yeah, so that's a great question. And in terms of the license and the cost, so the operator is essentially a version of our ngrok agent that is developed and built and optimized to run in conjunction with Kubernetes. So when you purchase an ngrok plan, you'll have access to this operator, and you'll be able to install it and start stuff up. In terms of, like, the licensing and the specific cost, it depends on the amount of resources that you plan on creating with the operator itself. So that cost will be based on the plan you select and what your specific needs might be. This is a great question to email support about. And so, Paolo, if you want to email support@ngrok.com, with like your specs or like with what you're thinking of using ngrok with, we can give you the best possible plan for your use case. We have another question. Is there a way to monitor the up running services? That is a great question. When you say up running services, are you referring to the services that like an agent endpoint might be directing traffic to within your cluster? I'm not sure if they have a way to respond, but
yeah, it seems like that would be kind of the path that we're headed down, that question of like, does ngrok offer a way to monitor the requests, that like whether it is with the CLI or with the operator, like can you see what's going on, right? And the answer to that is yes. We have a feature called Traffic Inspector. We can try to, if you have an account, let me just grab the link to it here. You can see traffic as it comes in live to your endpoints. And let me just show you. I'm going to use my own accounts here, like my own request here, to show what this looks like, because I don't want to like put anyone else's IP address. Oh, I guess that, yeah. Like you can see these requests as they come in. If I turned on full capture, you'd be able to see like what is the body that's coming in, what are all the headers. So really powerful way to kind of like see everything that's going on in your ngrok account, whether it's your own traffic or customers or anything like that. Super, super powerful. And you can also export that data to other places like Datadog or CloudWatch or other places that let you kind of store and build from structured logs. Awesome. All right. Yes, and you can also see it locally as well. So one last thing to show with kind of this 101 level of the ngrok operator, and then I promise, Sachin, we will get to your your demo as well, and give you some time to show off some of the things that you've been building. So, the ngrok operator on its own is very powerful. Super simple way to have traffic come into your Kubernetes cluster, and like just very, very minimal networking required to be able to get that up and running. With other solutions, you still have to set up like load balancers and DDoS protection and all this stuff. And we just collapse all of that into the operator and into this kind of like custom resource manifest that I just showed you a moment ago. But as you notice in maybe this curl commands, like you have to hit this /API/generate path. And maybe that's not like as useful or as intuitive as you would like it to be. So what I'm going to do is maybe make that a little bit more user-friendly. And I can do that by using a traffic policy action that lets you rewrite URLs. So let's take a look at what that looks like. So traffic policy is this engine that we have that lets you manipulate and shape and take action on traffic. It has a ton of power, many different things that you can do. And it works no matter where you are using ngrok, like on the CLI, on a cloud endpoint, or in Kubernetes. This file is almost identical, except that we've added a traffic policy, and that we're saying on every HTTP request, we want to rewrite this. We're going to say /LLM to /API/generate, which is the kind of the default. We just want to do /LLM. It's a little bit easier and just like adds this kind of nice experience to using it. So we are going to apply this on top. We've kind of reconfigured the existing agent endpoint, and this should work just as it did before. And the request, as it kind of enters the ngrok network, will be like shaped by traffic policy, so that we get the same result, even though we're hitting the different path. It's handling rewrites for us, and you can do a ton of stuff with traffic policy You can rate limit, you can add authentication, just the sky's the limit in the way that you can configure these pieces together to get the Kubernetes ingress that you need. So yeah, that kind of concludes my maybe too long demo about how the ngrok operator works. We've published a lot of docs, and we're publishing a lot of content this week and next week that kind of detail a lot more specific use cases of the operator and different ways that you can mix and match endpoints and traffic policy and all of their goodness. But if you use the operator and have issues with it or have suggestions on how we can make it better, please reach out in one of the many ways. My email is in the chat. I'll also put support. We would love to hear from you and use your feedback to make the operator better. So yeah, with all of that said, it looks like we're pretty well caught up on questions, although maybe
got a couple new ones.
We've got Jay is asking routing traffic across services in different namespaces. Sachin, I think this is something that you were just having some issues with yesterday. What did you find there, and like how does the operator and namespaces work?
Yeah, absolutely. So to answer your question, Jay, yes. Let's say if you create a namespace that your service is running in, and you want traffic that's going into that service once it flows out of it to go to another service, you can use our ngrok custom resources within Kubernetes to route to different route to different namespaces. You can also use our like gateway API method as well as like our ingress method to do so. So you have a couple different options, and after towards the end of office hours, I'll go and find the exact links to the docs that can give you more information on that. But also in my demo, you'll get a little taste of how that might play out in a use case. But to answer your question, yes.
Perfect. Sachin, do you want to jump straight into your demo, and I'll kind of answer a few of these questions in the chat if I can. But just to be cognizant of time, and you put a lot of effort into this demo, so I'd love to make sure you've got the time to be able to do that.
Yeah, absolutely.
Awesome.
So I'm gonna go ahead and present. I think that's what it does. Yeah, share screen. Oh, I gotta. Okay, I have to quit my browser to give StreamYard access to my screen.
I was muted. No worries. Yeah.
Okay, I'll be right back.
Take a moment. I'll be here. I'll answer some questions. Yeah, Jay, hopefully that Sachin's answer kind of helped you with namespaces. The one nice thing about the Kubernetes operator is that it's when you install it, we recommend, or by default, it installs into the ngrok -operator namespace. But by default, it will listen to and kind of like create ingress no matter where your services, like which namespace your service is running in. So you can have services running in a dozen different namespaces, but as long as you create the appropriate ingress resource for it, whether that's the Kubernetes ingress or gateway API, or you use our custom resources, as long as you specify in that you want to use the ngrok operator, then it will pick those services up and create ingress into them automatically. So hopefully Sachin gets back up and running in a moment, because his demo is indeed very exciting. Any other questions about Kubernetes things, or I guess ngrok in general? Otherwise, I might see if you also asked a question in the registration form and you are here. Unfortunately, I can't see a list of everybody who's present, but would love to, if you are here, but would love to be able to answer that question for you. All right, Sachin, we've got you back up on stage. We can see your screen. So welcome back. Let's jump into it.
Cool. So I'm going to go ahead and demonstrate a very bare bones example of a use case that uses our Kubernetes bindings. So kind of going into what do we mean when we say bindings? So these bindings refer to where your ngrok endpoint can be accessed from. So for Kubernetes, if an endpoint is Kubernetes bound, that means that endpoint is only accessible from within the cluster that you install the ngrok operator within. I know that sounds kind of convoluted and weird because the whole point of external ingress is to make your local services public, but there's a reason for this because let's say if you have certain services that are running within a cluster, you want to access them from another cluster, but you don't want to publicly expose your resources over the internet. So I'm going to go ahead and show a couple different examples of how these bindings play out with ngrok. So let's say we have an API deployment here, and this API, what it does is when you hit this endpoint, it just gives you information about um, the client that's sending the request. So I can go ahead and show you guys what this example might look like. So we'll get back to this screen in a bit, but here we go. We have this API that just says, "Hey, Pong from ngrok. Here's the host, and here's some information about the client that's sending the request." So you might be asking yourself, like, okay, cool, this is a public URL. Where is this code running? So this code is running within this Kubernetes cluster that I have locally on my laptop. And the way I've gone ahead and exposed this is with ngrok custom resources. So here we have the deployment file. We have our service and our deployment. And now I'm going to show what a cloud endpoint with Kubernetes might look like. So if we have this service, and let's say just as a bare bones example, I want to expose this service publicly. So what I can do with the the Kubernetes operator is create this YAML file that declares a resource of type cloud endpoint. And when you install the operator and when you install the operator and declare this resource as a cloud endpoint, what the operator does is that it basically kind of shoehorns the ngrok custom resource into the Kubernetes API itself. So when your cluster is creating resources, it's creating resources in a way that the Kubernetes built-in system understands, and it's able to also project this information up to the ngrok cloud so that you can centrally manage and also see all of your resources that you're creating. So if I go to my ngrok account right here, we can see that I have this cloud endpoint that I just created via my YAML file.
Hey, Sachin, just don't mean to interrupt, but I think we can only see the terminal and not
okay.
if you're showing the dash, but like maybe that's not super important. Just wanted to let you know.
Okay. Yeah, appreciate you letting me know. Okay, you can only see my code editor. Okay, let me.
Yeah.
Is there a way to share the entire screen?
There should be.
Entire
Yes.
screen. There we go. There we go.
Okay. Perfect.
That's what it was. Awesome.
We'll bring
There
that
we
up.
go.
There we go.
Yeah, so like I was saying earlier, you can see in the ngrok dashboard that in the same way you would apply a deployment file to a Kubernetes cluster using the kubectl apply command, you can apply the YAML file that I was showing earlier, and that resource that you created will show up here. So what we've also done with this cloud endpoint is we've applied a traffic policy. And what traffic policy does is that it allows you to manipulate, route, and modify traffic that's coming into your endpoints using CEL expressions and YAML. So it's a very powerful tool that you can use to route, as we had a question earlier, about routing between namespaces. So this would be a great example of if you have different paths on in your application. Like let's say you have for example, a route to dev path and a route to prod path. With traffic policy, you're able to take stuff that might be in the URL path, stuff that might be in the headers, and based on that information, direct traffic to wherever you need. So kind of going back to the demo. So I have this version of this API in this cluster, and let's say this is my production version. But if I want to make changes, or let's say something happens to it where it's not behaving as expected, I don't want to. And if let's say I have a local copy of this API on my machine that I'm developing to see if I can fix this. So now what we have in this window right here is another version of this API, but it's running in a cluster it's running in a separate cluster. So now we're going to get into how we route from cluster to cluster with ngrok. And so what we have here is we have our same service and deployment setup, but this is running in a separate cluster. And if I wanted to get traffic from my other cluster to this one, I can use something called an internally bound endpoint. So going back to what we were talking about bindings, when you have an internal binding, this endpoint is only accessible from other endpoints within your ngrok account. So we have this internal binding here, and I'm declaring this URL. So this will be a URL that will refer to this type of endpoint. And I also want to point out that notice that we have a different kind of resource here. So we had cloud endpoint here and agent endpoint, and both of these are treated the same way. So if you wanted to apply this endpoint, you just use the kubectl apply command. And what's happening here is that we have an API endpoint. An ngrok URL here, but what it's routing to is actually a service that's running in a different cluster. So now we're going back to this cluster that we have here, and we have this API demo service that's running in this demo env environment. And if you notice that the URL here and the upstream URL in the agent endpoint here are the same. So what's happened here is that we're basically routing traffic to this other endpoint based on certain rules or certain configurations. And I also now want to bring up this concept of a Kubernetes binding. So why do we have Kubernetes bindings versus internal bindings? Basically, when you're, like I was saying earlier, it's just a way for your services to be more secure. And in terms of how to access them, this is a way that you can ensure that stuff isn't running through the public internet, but it is getting to where it needs to go. And so going back to the traffic policy that I was saying earlier, I applied this traffic policy here where if the URL path starts with route to prod, I want it to route to the service I have running within this cluster. And if it says route to dev, I want it to route to the copy of this API that I have running in my other cluster. So I can show you what this looks like. So right here, I've just queried this route, and you see Pong from ngrok production version. And that is great because that is what we see running here. And when we go to the other path, and I will preface this by saying that when I was working on this earlier today, I did break something. So this route to dev path is not live, but I can show you how this would play out from a Kubernetes standpoint. So here I have a terminal, and I'm running this. I've configured this terminal so that the context it's using is the cluster that I'm using for development. So if I go kubectl get svc to get all the services, I see the API demo service that I've declared in my deployment file. But then I also see this Kate's bound service as well. And so what this Kate's bound service really is that it's this Kubernetes bound endpoint that we've declared, but we're seeing how it's represented from within a Kubernetes cluster standpoint. So essentially, what this Kubernetes binding has done is it's taken this agent endpoint and projected it as a service, so that that service is now accessible from wherever you need it to be accessible from. So I can basically, with Kubernetes bindings, I'm making it seem that this cluster, which is for development purposes, is appearing in my production cluster. So test it, if I wanted to test it in production, this would be the way that you could go about doing that. And I know that was kind of in the weeds. I know there was a lot of code being shown, but the main point I really just want to drive home is that the advantage with ngrok in terms of like load balancing between clusters, routing between clusters, is that you don't need an extra ingress service. You don't need an additional proxy service. When it comes to updating your clusters that are in production or maybe running remotely, you don't have to go through a lot of Docker build, upload, and pulls. And also, at the end of the day, there's a lot less YAML code here to set up this intra cluster routing versus how you would normally need to do it. So yeah, that's kind of like we talked about bindings, we talked about some custom resource stuff, we touched a little bit on traffic policy. But yeah, that's kind of what I wanted to show everyone today. But yeah, happy to field any more questions.
Amazing. Thanks so much. Yeah, I think that's a really cool like demonstration of the power of like how you can pair these things together and sort of chain them or route them together to create some really powerful use cases. And as Sachin, you said, like what we think of as the big value of using ngrok with your Kubernetes cluster or clusters, like whether you just have one or many, is that in other cases, as you said, like you have to set up I don't know, VPNs or VPC peering, NAT stuff, like all of these really complicated, like cloud specific, difficult to understand networking pieces that are like not usually the core competency of any team. Like even an infra team, like doesn't necessarily want to know all of the nuance of those things. And with ngrok, they like simply don't have to. They can just like get things up and running and let developers or other people run with the cluster that they have up and running.
Yeah. One thing I want to add is with Joel's demo earlier about where he had a self-hosted LLM running that he wanted to expose. With bindings, you could use Kubernetes bindings to do something very similar. Where let's say you wanted that locally running LLM to be receiving requests from that were originally intended for a cluster that's running in GCP, AWS, have you. You are now able to do that in a much less intricate way. So with the ngrok custom resources, that's really the advantage that you get.
Awesome. And
Uh,
we love this this comment from
yeah,
Gavin. Yeah, being as Sachin said earlier, when there was a question about licensing or cost and like the operator itself being open source, and that you only incur costs for like the resources that you create, you really have a lot of control over how this works. And then you're also not stuck with Azure forever. If you want to move to a different cloud provider, if you want to go DigitalOcean or Vultr or whatever, any of the other options that aren't even the big three, you are free to do so, and nothing with how you've implemented ngrok changes between them. Looks like we've got a question from Eric here about. So once you are binded to the other Kubernetes, if that is running Olama, for example, can you send requests and get answers again as if it was your Kubernetes?
yes. So I think what you say when you say as if it was your own Kubernetes cluster, I think it means like if you have two clusters, one locally, one remotely. So Yes. So when I was earlier when I was showing that a new service was being created, that service can now be routed to from that other tape that that I think you're talking about in your question.
Yeah, I think the general answer here is yes, and that we can like yeah, no matter where you're running like a cluster or Olama, like whether Olama is running, you know, separately or whatever, you can use bindings to kind of bring the two together, and that is very cool. On top of just the regular ingress stuff that we've been talking about a lot. Um, Awesome. Well, we've got just a few minutes before the top of the hour. I appreciate a lot of folks sticking around for almost a full hour here as we go through this Kubernetes stuff. And I feel like we've honestly just like scratched the surface of
Yeah.
all of the Kubernetes things that we want to talk about in the near future. So with that in mind, we'll kind of bring things to a close here. Again, if if you have a question that you think of after the fact, or you asked a question and we missed it somehow, I'll drop emails for myself and our support team. Feel free to reach out to either of those two, and we'd be happy to kind of get you set on the right path. We have a lot more to talk about Kubernetes wise, so stay tuned to our blog. If you're not subscribed to our newsletter, that will be going out in about 2 weeks, and we'll again reiterate a lot of what we talked about today, and really try to get you caught up to speed on how ngrok thinks about Kubernetes ingress. So yeah, next month we've got the next session already scheduled for May 14th, same time, same place. We will be, I think, talking about some really interesting and dead simple ways to do load balancing, which I am very excited about, and because that is a huge problem that we heard from a lot of folks, especially at KubeCon EU a couple weeks ago in London. So very excited to talk about that in more detail. But until then, Sachin, thank you for hanging out with me and going through your demo. Super appreciate it. Thank you to Aishika for hanging out in the background and helping answer some questions. Really looking forward to having you on these a lot more, and letting you engage with the community a lot more. And thanks everybody for joining, and we will see you on the next one. Bye-bye.
Thanks, everyone. Take care.